Hi everyone. Today I am going to discuss the second half of paper 1 variant 3 A levels maths 9709 May June 2018. So I'll discuss question 7 till question 11 in this video. So let's start. Question 7. Express tan square theta minus 1 over tan square theta plus 1 in the form a sine square theta plus b, where a and b are constants to be found. Okay, so we got tan square theta minus 1 over tan square theta plus 1. Okay, this tan can be written as sine over cos, so tan square can be written as sine square theta over cos square theta minus 1 over sine square theta over cos square theta plus 1. So we can take LCM. LCM of the upper part, which is cos square theta, and we'll get sine square theta minus cos square theta. The LCM of the lower part, again cos square theta, and this will become sine square theta plus cos square theta. So this cos square theta will be cancelled with this cos square theta, and we're left with sine square theta minus cos square theta over sine square theta plus cos square theta. And we know this sine square theta plus cos square theta is 1. This is the famous trigonometric identity. So that's why this will be over 1, and we're left with sine square theta minus cos square theta. So you can see in answer we need sine square theta only. We cannot see any cos square theta. So we need to change this cos square theta into sine square theta. And I hope everyone knows that cos square theta is equal to 1 minus sine square theta. This is also a very famous identity. So this will become sine square theta minus 1 minus sine square theta. So this can be written as sine square theta minus 1 plus sine square theta, which can be written as sine square theta plus sine square theta, 2 sine square theta minus 1. So this is our required answer. We have written this in the form a sine square theta plus b, where a is 2 and b is minus 1. So this is our answer. Part 2. Part 2 is, let me check if I have the next page. No, I have this working area only. So hence or otherwise, showing all necessary working, solve the equation tan square theta minus 1 over tan square theta plus 1 is equal to 1 over 4. This is our limitations. So don't forget these limitations. Okay, so we got tan square theta minus 1 over tan square theta plus 1 is equal to 1 over 4. So it means in the previous part we have solved that this tan square theta minus 1 over tan square theta plus 1 is equal to 2 sine square theta minus 1. So we'll use this result here. Instead of this, we'll write this one. So this will become 2 sine square theta minus 1 is equal to 1 over 4. So this will become 2 sine square theta is equal to 1 over 4 plus 1, which is, after taking LCM, 5 over 4. So take 2 on the other side as well. So we'll get sine square theta is equal to 5 over 8. And after taking square root of both sides, so we'll get sine theta is equal to plus minus 5 over 8. Now, so I have to keep myself in this space. So now I got two values. Sine theta is equal to plus 105 over 8 and sine theta is equal to minus 105 over 8. So this will not move with this value because sine positive is in first and second quadrant, and our limit is in 0 and minus 90. This is the fourth quadrant, so we will not proceed this value because this is out of our limitations, so cannot be processed because this value is out of our range. So we'll proceed with this one. All right, so we'll get theta is equal to sine inverse minus under root 5 over 8. So this will give me theta is equal to minus 52.2 degrees. So this is our answer in this limit. No doubt sine is negative in second and fourth and third quadrant, but third quadrant is again out of this range, so we'll just write the answer in the fourth quadrant only. That's why this is our answer. Part B. The diagram shows the graph of y is equal to sin x and y is equal to 2 cos x for pi and minus pi. This is our domain. The graph intersected at the points A and B. So find the x coordinates of A, because these two curves got 2 points of intersection. One is A and one is B. A is in the first quadrant and B is in the third quadrant. So for finding the these points of intersection, we need to solve these two equations. So one is y is equal to sin x, and other is y is equal to 2 cos x. So put this value of y here instead of y, we'll write sin x. So it will become sin x is equal to 2 cos x. Take cos x on the left, so sin x over cos x is equal to 2. It can be written as tan x is equal to 2. So x will be tan inverse 2, which will give us 1.11. Don't forget to change your calculator to radian mode because this question is in radian mode. So this is the value of x, because A is in the first quadrant. Because if we plot a quadrant graph, tan is positive, it means we will be in first and the third quadrant. So this is actually our alpha. This is alpha, so we got 2 1.11 here and 1.11 here. So in first quadrant, alpha and x are same, so that's why this is our value of x, because a is in the first quadrant. But find the coordinates of b in the second part. Now b is in the third quadrant, so we'll use the third quadrant value, which is our theta will be pi plus 1.11, because this is our theta, this one, this whole. So for b, we need to find the value of x in the third quadrant, which is x is equal to pi plus 1.11, which is 4.25 radians. So this is our second value, which will be used for the coordinates of b. So we'll put this value of x here, y is equal to sine x, and we'll get the x coordinate of point b. So y is equal to sine 4.25, and this will give us y is equal to minus 0.89. So this is the y coordinate of point B. Don't forget to change your calculator into radian mode. So this is the answer of part B. Question 8. The tangent to the curve y is equal to x cube minus 9x square plus 24x minus 12 at a point A is parallel to the line y is equal to 2 minus 3x. Find the equation of the tangent at A. Okay, so we got y is equal to x cube minus 9x square plus 24x minus 12. This is the equation of curve. So for the value of gradient, we need the derivative of this to find the value of gradient at this point. So for tangent, we need derivative, that is dy by dx. So this is 3x square minus 18x plus 24. So this is the value of this is the tangent, value of tangent at A, but this tangent is also parallel to this one. Y is equal to 2 minus 3x, or I can write it as minus 3x plus 2. If I compare this equation with y is equal to mx plus c, so this is the gradient of this line. Now the tangent of this curve and this line are parallel. The tangent of this curve is actually this one, so they both are parallel. It means they have the same value. Therefore dy by dx has the same value, which is minus 3, the gradient of this equation. So these two gradients should be same, that's why dy by dx should be equal to minus 3. So put this value here, it will become minus 3 is equal to 3x square minus 18x plus 24. So take 3 on the right side, it will become 0 is equal to 3x square minus 18x plus 24 plus 3, or I can write it as 3x square minus 18x plus 27 is equal to 0. So take 3 common, it will become x square minus 6x plus 9 is equal to 0. Since 3 cannot be 0, therefore x square minus 6x plus 9 should be 0. Okay, I'll solve it by midterm break method. It will be x square minus 3x plus 9 is equal to 0. X common x minus 3 common x minus 3 is equal to 0. So x minus 3 common, x minus 3 is equal to 0. So this equation got repeated root, that is x is equal to 3. Now this is the a coordinate of point A. So for x coordinate for the point A, this point A. So for y coordinate, I'll put this value of x in the curve. I'll get the y coordinate of A. So I got curve x cube minus 9x square plus 24x minus 12. So put the value of x. So this will become by putting value of x is equal to 3. So this will be y is equal to 3 cube minus 9 into 3 square plus 24 into 3 minus 12. Okay. So this will be 27 minus 81 plus 72 minus 12. So after solving all this, y is 6. Therefore, we got coordinates of A which are 3 and 6, and the gradient, that is dy by dx, which is m, that is minus 3. So we got point and gradient. So by using the gradient point form, we can find the equation of tangent. Therefore, equation of tangent at A will be y minus y1 m x minus x1. This is the gradient point form of the equation. So x1, y1 are the actually coordinates of A, and m is the gradient. So y minus gradient y coordinate of A is 6, m is minus 3, x minus x coordinate of A is 3. So y minus 6 minus 3x plus 9, or take 3 on the left side and 6 on the right side. So y plus 3x is equal to 9 plus 6, or it can be written as 3x plus y is equal to 15. This is the equation of tangent at A, which is our answer. Part 2. The function f is defined by f(x) is equal to x cube minus 9x squared plus 24x minus 12 for x is greater than k, where k is a constant. Find the smallest value of k for f to be an increasing function. Okay, we got function f(x) is equal to x cube minus 9x square plus 24x minus 12. So for the function to be an increasing function, the gradient should be positive. Means the function should be, the line, the tangent line should be in the positive direction. So for this purpose, it means the derivative of this function should be positive. So for derivative, it will be f dash x, which is 3x square minus 18x plus 24. Since f is an increasing function, therefore f dash x should be greater than 0. This is the condition for increasing. So that's why this value should be greater than 0. 3x square minus 18x plus 24 should be greater than 0. Or take 3 as common. So x square minus 6x plus 8 greater than 0. 3 is always greater than 0, so that's why this value should also be greater than 0. Okay. For critical values, we'll solve with the critical values. For that purpose, for critical values, we'll consider this equal to 0 for a moment. X square minus 6x plus 8 is equal to 0. Solve it by midterm break method. X square minus 4x minus 2x plus 8 is equal to 0. X common x minus 4 minus 2 common x minus 4 is equal to 0. X minus 4 common x minus 2 is equal to 0. So I get x is equal to 2 and 4. These are the two critical values. Okay. For inequality, there are 2 or 3 methods, but I always use this method, which is quite easy for the students as well, the graph method. This is 2 and this is 4. So this is actually a positive coefficient of x. The parabola will be cup shape, means it will open upwards. It will be like this. So greater than 0 means the outside area above x-axis is our answer region. So this will be x is greater than 4 and this will be x is less than 2. This area will be this one and this will be this one. Now, because it is given in x is greater than k, so we'll choose this value. Therefore, the smallest value of k for this function to be increasing is 4. So this is our answer. Question number 9. The diagram shows a pyramid OABCD. This is a pyramid OABCD with horizontal rectangular base OABC. This is a rectangle. The sides OA and AB have lengths 8 units and 6 units respectively. These are the lengths you can see. The point E on OB is such that OE is 2 units. The point D on the pyramid is 7 units vertically above this one. Unit vector I, J, K are parallel to OA, OC and ED. Okay, respectively. Show that OE is 1.6 I plus 1.2 J. So part 1. Okay. For this purpose, we will find OB first. What is OB? This is OA plus AB. This AB is in the direction of OC, so I can write it as OA plus AC. So OA is 8I because there is I unit vector along OA and J unit vector is along OC. So this is 8I plus 6J. This is OB. But if we see that OB is by Pythagoras theorem, OB is 8 square plus 6 square. If we apply Pythagoras theorem, because these are right angle, this is right angle, it's a rectangle. So this will be 64 plus 34, 6, which is 100, and that is 10. So it means OB is 10. But OE is just 2 units. It means OE is 2 by 10 of OB. This is 2/10 part of OB. So that's why it will be 2 over 10. What is OB? OB is 8I plus 6j. So if we multiply this 2 by 10 inside, so this will give us OE is equal to 1.6i plus 1.2j. This is our answer. This is shown actually. Okay. Part 2. I got the next page, hopefully. Yes, I got the next page as well for the working. So I should be more confident. Part 2. Use a scalar product to find the angle BDO. If you see the figure BDO, this is the angle BDO. So for this we need to find two vectors OD and BD. So when we'll find these two vectors, then we'll go for the cosine dot product. Sorry. So first of all, we'll find OD. So OD will be actually OE plus ED, OE plus ED. So this is OD. So we'll go like that, OE plus ED. So what will be this? This will be OE. We found OE in the previous part. 1.6i plus 1.2j, and ED is this ED is salmon k, because this is along k. So this is salmon k. This is our OD vector. Second vector which we need to find is BD. So this BD vector, this vector we need to find, BD, this one. So for BD we'll go BO and OD, BO and OD. So this will be BO plus OD. So BO is opposite of OB. So BO is opposite of OB. OB is 8i plus 6j. It means we'll use the negative of this, which will be minus 8i plus 6j, minus 8i minus 6j, and OD is this one. We already found this OD here. So this will be plus 1.6i plus 1.2j plus 7k. So after solving it, it will become so after solving, minus 8i plus 1.6i means it will be 6.4i, minus 6j plus 1.2j means minus 4.8j plus 7k. This is our BD. Now we know the dot product by the dot product of two vectors. BD vector dot OD vector is equal to BD vector magnitude into OD vector magnitude cos BDO. So therefore take these two things on the left side. So I'll get cos BDO angle is equal to BD dot OD over BD magnitude into OD magnitude. So I'll put the values here in the next page. So from the previous page I got cos BDO DO is equal to, I have to write it again so that I do not turn the page again and again. BD dot OD vectors over BD magnitude dot OD magnitude. So by putting the values, BD vector is minus 6.4i minus 4.8j plus 7k into OD vector is 1.6i plus 1.2j plus 7k over the magnitude of this. It will be like minus 6.4 square plus minus 4.8 square plus 7 square. The magnitude of OD, which is 1.6 square, 1.2 square, 7 square. So I'll multiply these two vectors, I will multiply with I, j with j, and k with k. So minus 6.4 multiply 1.6 will give me minus 10.24. Minus 4.8 multiply 1.2, this will be minus 5.76, and 7 multiply 7, this will be plus 49 over, after solving all this will give 113, and this will give us 53. So cos BDO is, this will give us 33 over, this will give us 77.38 after multiplying them. So the angle BDO is equal to cos inverse 33 over 77.38. So this will give 64.75, which will be 64.8 by 1 decimal place. So this is angle BDO. This is our answer. Question 10. The 1 function f is defined by fx equal to x minus 2 whole square plus 2 for x is greater than c, where c is a constant. State the smallest value, possible value of c. So the smallest possible, because this is a cup-shaped parabola which is opening upwards, so it will turn at 2. This is the turning point, value of turning point. That's why this will be the smallest value of constant c, which is obviously 2, the turning point of parabola. So this is 1 mark answer. That's it for this. Now in part 2 and 3, the value of c is 4. Okay, so you should keep in mind now that the value of c is 4 now. Find an expression for f inverse x and state the domain of f inverse. Okay, we got fx is equal to x minus 2 whole square plus 2. Now we'll find the inverse of this function f. For this, there are certain steps which everyone should know. Let y is equal to fx. So I'll put y instead of fx. It will become y is equal to x minus 2 whole square plus 2. So I'll try to make x the subject of this expression. So take 2 on the left, y minus 2 is equal to x minus 2 whole square, or I can write it as x minus 2 whole square is equal to y minus 2, taking square root of both sides. So this will be cancelled with the square, and I'll get x minus 2 is equal to plus minus y minus 2, but I'll not take the negative value because the c is 4, constant is 4, that is it is a positive value. So that's why I'll take only x minus 2 is equal to y minus 2. So take 2 on the right side, x will be y minus 2 plus 2. Now I'll write f inverse x instead of x, and I'll exchange all y's with x. This is the procedure of finding f inverse x. So this is the expression for fx. Now for the domain of f inverse, domain of f inverse is actually equal to range of f, because this is the inverse of fx. So domain of f inverse is actually the range of fx. So how we can find the range of fx? From here. So we got fx is equal to x minus 2 whole square plus 2. Now because x is greater than equal to c here, this one, but c is 4, so it means x is greater than equal to 4 here. So put 4 here, the minimum value, that will give us 4 minus 2 whole square plus 2, that is 2 square plus 2, 4 plus 2, which is 6. So this is the range of fx. Therefore domain of f inverse x will be greater than equal to 6. This is our answer. Part 3. Solve the equation f of x is equal to 51, giving your answer in the form a plus under root b. Okay. So we got f of x is 51, but our main function fx is x minus 2 whole square plus 2. So for f of x, actually we have to go like this. It means function of fx. So we'll have to replace this x with fx in this expression. So this will become where there are x, we'll put fx. fx minus 2 whole square plus 2. So put the value of fx again here, x minus 2 whole square plus 2, and this is minus 2 whole square plus 2. This will be cancelled with this one. So we're left with x minus 2, this 2 and this 2, they will multiply and will become 4 plus 2. F of x. But the value of f of x is 51, so we'll put the value here. This will become 51 is equal to x minus 2 power 4 plus 2. Take 2 on the left side. So 51 minus 2 is equal to x minus 2 power 4, or I can write it as x minus 2 power 4 is equal to 49. So taking square root of both sides, it will become x minus 2 square, because the square root will change this 4 into 2, and plus 7. Now, why not minus 7? Because again the value of x is c is greater than 4, so 4 is positive, that's why will not take negative. So again take square root of both sides, so this will become x minus 2 is equal to 7. Again we will not take negative, so take 2 on the right side. X is equal to 2 plus under root 7. This is the solution in the form a plus under root b. This is the form. Last question, 11. The diagram shows a part of the curve y is equal to x plus 1 square plus x plus 1 power minus 1 and the line x is equal to 1. The point A is the minimum point on the curve. This is the minimum point. Show that x coordinate of A satisfies the equation. Okay, and find the exact value of d2y over dx square at A. Okay, so we got the curve y is equal to x plus 1 square plus x plus 1 power minus 1. This is our equation of main curve. So we need to find the derivative, because we are dealing with the tangent of the curve at A. So dy by dx is actually, this will be 2 into x plus 1 plus power minus 1 x plus 1 minus 1 minus 1. So this will be 2 into x plus 1 minus x plus 1 raised to power minus 2. Or we can write it as dy by dx 2 into x plus 1 minus 1 over x plus 1 whole square. Now at A, this is the turning point, so the tangent at A will be parallel to the x-axis, means the gradient will be 0. So at A the gradient should be 0. At A, the gradient of the curve, which is dy by dx, it should be 0 because it is parallel to the x-axis. This is the turning point of the parabola. So I can write it as 2 into x plus 1 minus 1 over x plus 1 square is equal to 0. Now take this on the other side. 2 into x plus 1 is equal to 1 over x plus 1 square, or take this on the left side by cross multiplying, it will become 2 into x plus 1 cube is equal to 1, because this will become square and multiply power 1 cube. So this is shown. We need to show this in this form. Okay, so I hope I got the left. No, this is the only page, so I'll have to divide it into 2 parts. For second, we need to find the value of d2y by dx at A. So we got dy by dx, which we already got, 2 into x plus 1 minus x plus 1 raised to power minus 2. This is this one. So again, taking the derivative with respect to x, this will be d2y over dx square, and this will become 2 minus power minus 2 x plus 1 raised to power minus 3. So this will be 2 plus 2 over x plus 1 raised to power cube. Okay, from here we can see that x plus 1 cube is equal to 1 by 2 if you take 2 on the other side. So this can be written as x plus 1 cube is equal to 1 by 2. So I'll put a 1 by 2 instead of x plus 1 cube here. So this will be 2 plus 2 over 1 by 2. This will be 2 plus the 2 will multiply with 2, that will be 4, which is equal to 6. This is the exact value of d2y over dx square, which is our answer. Part 2. Find, showing all the necessary working, the volume obtained when the shaded region is rotated up through 360 degrees about the x-axis. So it is actually the volume of revolution. So we know the formula for volume of revolution is 0 till 1 pi is here y square dx. These are the limits. If you see the figure, you can see the limits 0 to 1. So this area is enclosed between x equal to 0 means y-axis and x equal to 1, and it is rotated about the x-axis through 360 revolution. So okay, pi 0 1. What is our value of curve? This is x plus 1 square plus x plus 1 raised to power minus 1 whole square dx, because there is y square. So this is the value of y, so I'm taking y square. So this will become pi 0 1. I'm going to open this square by a plus b whole square formula. So this will give me x plus 1 raised to power 4 plus x plus 1 raised to power minus 2, the square of this, plus 2 into x plus 1 square into x plus 1 raised to power minus 1 dx. Okay, pi 0 1 x plus 1 raised to power 4 plus x plus 1 minus 2 plus 2. Actually this will be cancelled with this one, because this is equal to 1 over x plus 1, so 1 x plus 1 will cancel the square, so we'll get 2 into x plus 1 only dx. Now I'm going to integrate this. So this will become the integration of x plus 1 raised to power 4 is x plus 1 raised to power 5 over 5. The integration of this part will be x plus 1 minus 2 plus 1, which is minus 1 over minus 1, plus this will be the integration of this is x plus 1 raised to power 2 over 2, 0 1. So this 2 will be cancelled with this one. Okay, so this minus will actually, okay, I can write one more step. So pi will be x plus 1 raised to power 5 over 5, this plus minus minus x plus 1 raised to power minus 1 plus x plus 1 square 0 1. I'm going to put the limits. First of all, I'll put 1 in all places of x. It will be 1 plus 1 over 5 power 5 minus 1 plus 1 raised to power minus 1 plus 1 plus 1 raised to power 2 minus this one. 0 plus 1 over 5 power 5 minus 0 plus 1 minus 1 plus 0 plus 1 power 2. So these are the limits. So pi, this will become 2 raised to power 5 over 5 minus 2 2 raised to power minus 1 plus 2 raised to power 2. This will be minus 1 raised to power 5 over 5. This minus will make this plus 1 raised to power minus 1, and this minus will make it this plus minus 1 raised to power 2. So this will be pi. 2 power 5 means 32 over 5. This means 1 over 2. This means 4 over 1. You can write 4 over 1. This will be 1 over 5. This will be 1, and again this will be 1. This will be cancelled with this one. We will not take them further. So take the LCM, which is definitely 10. So this is 64, this is 5, this is 40, this is minus 2. So this will become pi into 64 plus 40, that is 104, minus 9, minus 5, that is 99, minus 2, that is 97 over 10, which is 9.7 pi. This is our answer. So that's it. This is the end of the paper 1, variant 3, May-June 2018. So thanks for watching. See you in the next video. That's it.